Today we're going to start section 3, which is all about measurements. This is going to be split into several parts, and we're going to start part 1 today. So let's go ahead and get started. It asks questions like, how old are you? How tall are you? When you answer these questions, you're giving measurements. Measurements are important in both science and in everyday life. It would be difficult to do science if you didn't take any measurements. Already this year, we've done measurements several times. We learned how to measure volume in a graduated cylinder. We've also learned how to measure temperature using a thermometer. And even in this past lab, we measured time using a stopwatch. The first type of measurement we're going to focus on is scientific notation. And our key question we want to answer is, why is scientific notation useful? Scientific notation is something that you've probably seen in your math class. If you've ever seen something written as 3 times 10 to the second, this is an example of scientific notation. Since our key question asked, why is scientific notation useful, it is important to understand that scientists often work with very, very large numbers or very small numbers. Astronomers, or scientists that focus on learning more about the outer space, estimate that there are about 200 billion stars in our galaxy. That is a very large number, so using scientific notation helps us work with that number a little bit easier. So scientific notation is defined as a way of expressing a value as the product of a number between 1 and 10 and a power of 10. Now that's a big mouthful, so let's break that down. It is a product, so we know that we are multiplying two things, hence my multiplication sign. We're multiplying a number between 1 and 10. So this number has to be bigger than 1, but less than 10, so I'm going to put bigger. This is the number that goes in front, for example, 3.4. It is bigger than 1 and less than 10. The other thing that we're going to multiply, it says, and a power of 10, which means this is where you're going to put 10, and then there's going to be a number up here. This is considered your power or your exponent. So for example, 3. This would be your power / exponent. Let's start off by talking, what if we have a super, super big number like we did with the amount of stars? Another example of a super, super big number is the speed of light. It is about 300 million meters per second. In scientific notation, we like to write that as 3.0 times 10 to the 8th. The exponent, which is 8, is going to tell you the decimal places that you moved. So it tells you that the decimal point is really 8 places to the right of the 3. So, how did we go from this number to here? Well, what we did is, if you've ever seen a number and there is no decimal, you're going to assume that it is at the very end. What you're going to then do is move the decimal where the number in front is bigger than 1 but less than 10. So here we're going to move it over 8 times. So when you put the decimal here, 3 is bigger than 1, less than 10, times 10, and this up here is going to be an 8 because we hopped the decimal over 8 times to the left. Also, note that this is positive because this is a big number. On the opposite side, well, what if the numbers are less than 1? How do we write those in scientific notation? Well, it's very simple. The exponent would just be negative. For example, an average snail's pace is 0.00086 meters per second. This number right here is not between 1 and 10, so we have to move our decimal over until we get a number between 1 and 10. So 8.6 is between those two numbers, and then we count Well, we moved our decimal over 4 times to the right, and this is a very small number, so we know we get a negative exponent. That negative exponent tells you how many decimal places there are to the left of 8.6. So if you look at 8.6, notice that the decimal places is going to be 4 over. So this part is not written in your guided notes. This is a part that I added that I helped simplify things. So if you want to take out a piece of paper and write this down, this is a very good thing to keep handy. I'm going to break down how to change standard form into scientific notation. So what you're going to do is you're going to place the decimal point so there is one non-zero digit to the left of it. So what I mean by non-zero digit, I mean numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9. Any number that's not 0. What you're then going to do is you're going to count the number of decimal places that you had to move. This is going to be your exponent that you put on the 10. If the number was less than 1, you're going to make that exponent negative, and if it was greater than 1, you're going to make that exponent positive. So let's do a couple examples. We're going to want to put these numbers in scientific notation. Again, if you see no number or decimal spot, it goes at the end. In example 1, we have no decimal point listed there, so we can assume that it's at the very end. We want to move this so only one non-zero digit is in front of it. So we have to keep moving, and we can't leave it here because here this number is not between 1 and 10. So we have to keep moving it. Here, 4 is going to be between that 1 and 10, so we can leave our decimal there. So let's rewrite our number with our new decimal position. 4.0578. Then you can say times 10, because you'll always write that. Well, how many times did I move it? I moved it 1, 2, 3, 4 times. So you're going to put the number 4. Since you went to the left and this number is bigger than 1, the 4 stays positive. On number 2, if we were going to write this, we're going to have to move the decimal where there's only one non-zero digit in front of it. So right now, we have a decimal, so we're going to move it 1, 2, 3. 3.872. Notice that this number, again, is between 1 and 10. We're going to write times 10. And then how many spots did you move it? You moved it 1, 2, 3 spots. How do I know if this is positive or negative? Well, you're going to look at the number you have. If this number is bigger than 1, that's going to stay positive, but it's not. 0.003872 is less than 1, so this is actually going to be a negative 3. On number 3, we don't see a decimal, so again, you assume that it's at the very end, and you're going to want to move it where there's only one non-zero digit in front of it. So if we move it, we should get a 3. Times 10, well, how many times did I move it? 1, 2, 3, 4, 5, 6 times. How do we know if this stays positive or not? Well, notice 3,000 is bigger than 1, so it's positive. Down here, again, no decimal, so it's assumed to be at the end. Well, you can't move it left or right because there's already a non-zero digit in front of it. So this just stays 2 times 10, and since you didn't move it, 10 to the 0. The last one, you have a decimal, and you just need to move a non-zero digit in front of it. So here, you move it over one spot. Notice that 4.7826 is between 1 and 10, so you're good there. Times 10. How many spots did you move it? 1. And you're going to notice this number is less than 1, so this has to be a negative. Hopefully by now that you've seen a pattern. If you move decimal to the left, you're going to be positive. If you move decimal to the right, you're going to be negative. You can do the same thing by reversing it. If you are given something in scientific notation, you can put it back in standard form. You simply just move the decimal to the right if the exponent is positive, and to the left if the exponent is negative. And the reason for, since you're undoing it, you would do the opposite of what you did before. So let's do a little bit of practice. Here, express these numbers in standard notation. I'm given 4.7. And it's saying I have a negative 5. This tells me I want to move 5 places to the left. The reason for this is I want to make this number smaller. So you'll move the decimal 1, 2, 3, 4, 5. Notice that there's a bunch of blanks here. You fill those in with zeros. So zeros go in all those. So your new number is 0.000047. And you are correct. Here you have 9.87. And it says 10 to the 6th. Since this is positive, you're going to be going to right because you want to make this number bigger. So here's my decimal. We're going 1, 2, 3, 4, 5, 6. Notice I have all these blanks, so you're going to go ahead and fill them with zeros. And that will give you the number 987 with 4 zeros at the end. Over here, the negative tells me I'm going to move my decimal to the left 2 times. So 1.114. If I'm going to move that, I got to move it 1 time over, 2 times over. So I have to fill in a 0. 0.01114. Here, this tells me positive. I'm going to go to the right. So here I'm going to make this number bigger. So if I move to the right, I'm actually going to get 28. And then last but not least, this number is positive, so we're going to move to the right 9 times. So 6.678, and move it 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to fill in these zeros. So my new number becomes 6, 6, 7, 8, followed by 6 zeros. Now, just because we can put things in scientific notation, most of the time we use them because we like to multiply or divide in scientific notation. To multiply numbers in scientific notation, it's very simple. All you would do is multiply the numbers in front and add the exponents. So let's do the example about how light travels. Here are our 2 numbers that we want to multiply. So our 2 scientific notation numbers. It's telling us to multiply the numbers before the multiplication sign. So we're going to multiply the 3, because see, right, it's before the multiplication sign, and the 5. So 3 times 5 got us our 15. Then we're going to add the exponents. Remember, exponents, this little number up here, 8 and 2. So 8 plus 2 is what got us to 10. Now 15 is not in proper scientific notation because that number is not between 1 and 10. So we have to move my decimal over 1. Since I'm moving my decimal to the left, that actually adds 1 to my exponent. So here, you're going to add 1, and that's how they got the 11. So they're good. This is about the distance between the sun and Earth. Is 1.5 times 10 to the 11th meters. Dividing numbers is just slightly different. You're going to divide the numbers in front, but you're going to subtract the exponents. So here, the following example demonstrates how to calculate the time it takes from light from the sun to reach Earth. Here are the two numbers that we're dividing. Notice that the numbers out front, we're going to divide those. 1.5 divided by 3, that got us our 0.5, because that's 1/2. Then what we did is our exponents, you subtract them. So 11 minus 8, this is what got us our 3. Notice this number is not in proper scientific notation because the 1 in front is not between 1 and 10. So to do that, we move the decimal to the right 1. Since we moved our decimal to the right, we have to subtract 1 from the exponent, which is why we get 5.0 times 10 to the second. Here, let's do an example together. A rectangle parking lot has a length of 1.1 times 10 to the third meters and a width of 2.4 times 10 to the third meters, and it wants to know the area. So hopefully you've been in a class and you know that area is length times width. So we're going to take 1.1 times 10 to the third times 2.4 times 10 to the third. So when you do this, know that the first two numbers you're going to multiply in front for multiplication. So we're going to do 1.1 times 2.4 and see what we get. Hopefully you get about 2.64. Then, since we're multiplying, you're going to add your exponents. So 3 plus 3 gets me 6. Now we're just going to combine it. 2.64 times 10 to the 6th. Last but not least, our unit was meters. So meters times meters gives us meters squared. So our answer is 2.64 times 10 to the 6th. And then here, notice they just rounded it to 2.6 even times 10 to the 6th. Here are a couple more examples that we can work out and that we can try. Here we're multiplying again. So let's go ahead and do that. We get 7.6 times 1.5. So let's multiply those out front. We get 11.4. The exponents, remember we add those. So negative 4 plus 7 gives us positive 3. So we can go ahead and do 11.4 times 10 to the third. Now this is not in proper scientific notation because my number right here is not between 1 and 10. So I have to move my decimal to the left. And I get 1.14 times 10. Since I had to move my decimal to the left, that means that I need to add 1. So this is going to be times 10 to the 4th. Okay. Yep, so we're good. Don't forget my unit, meters squared. Down here, this is regular division over here. So if we're doing this, you can put this in the calculator as 0.00053 divided by 29, and you're going to get hopefully the answer on your calculator as 1.827586 e to the negative 5. If you ever see this on a calculator, this e means the same thing as saying 1.827586 times 10 negative 5. So that e just means that it's an exponent on a calculator. And that's the end of today's lesson. Let me know if you have any questions, and I'll be willing to help you. And I hope you guys have a good day.